Welcome back to Learning Solidity. Now in today's tutorial I'm going to be looking at developing Solidity contracts using Atom and Truffle. Now I know previously in the past I've almost used exclusively Remix. I have touched on a little bit of Atom, and I'm not sure if I actually touched on Truffle at all before, but I will cover it in today's tutorial. Now basically what Truffle allows us to do essentially is to compile, migrate and test our contracts in sort of a encapsulated environment. So essentially what we're going to need for today's tutorial is a couple of little tools. Now the first thing we're going to need, now you may have come across this in the past, is a very well known tool. It's called NPM, or the Node Package Manager. So that's obviously going to allow us to get hold of Node. You can do so by going to the npmjs.com homepage /get npm. Now I am going to leave links to all the web pages in the description box down below, so don't forget to check those out if you missed any of this. Now all you have to do is simply, especially if you're using Windows, which I'm going to be using for an example today. I do use this in Linux as well. I've not actually tried it on a Mac, so I'm sure it's very straightforward. I can guarantee it's very straightforward on a Mac. Now all you have to do is just simply click on, obviously, download Node.js and npm. Now that will probably give you a prompt for an installer. Obviously I'm not going to take you through an installer on these videos, it's very straightforward. Once you've got npm installed, the first thing you're going to need is Truffle. Now Truffle is, like I say, this is the compiler tool, but once you actually have npm installed, you don't need to download anything per se. What you need to do is get yourself a little terminal. Now I've got one here. Now to install, I'm just going to give you a very quick overview of the example here. So we state in npm install -g. -g actually indicates a global installation. Now if you do a installation of npm, what it will do traditionally is install those node packages locally or to a local directory, and I think it's called node modules, or a folder called node modules. So doing the -g flag, it installs it for all of your profiles, so you can use it universally. So if I do -g and then Truffle, now obviously in Linux I think in some cases you might need to sudo that command. I think I actually did. I'm not sure if you have to, but either way. And as you can see there, it's updated Truffle to version 3.4.11. I think it was actually 3.4.10 before then. So if I'll run Truffle, I get this list of commands, and it can also confirm it's installed. I can also run Truffle version and just check on the version I've got installed, which is obviously going to be the one here, so 3.4.11. And now with that installed, we need a test environment. We could use the testnet if we wanted to. We could obviously use one of the pre-existing test networks, such as the Romston. I can never pronounce that right, or Wrinkleby networks, or any of the other test networks essentially, or we could use the Ethereum.js TestRPC. Now I actually really like this TestRPC, and for today's tutorials you're actually going to need this, because when I was testing this out previously, trying to run the tests on one of the other test networks caused me a lot of problems. So for this, I think it's actually a minimum requirement that you actually have the TestRPC installed. Now, similar to our previous installation, again, we're going to need to do the npm install. So npm install globally Ethereum JS and TestRPC. If I spell it right, let's see if that works. Let's see if it finds anything. It should do, hopefully. It's doing something. Yes. Skipping optional, blah 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 blah. But either way, it's now installed. And what now this is giving us access to is the TestRPC, which is is basically allowing us to execute this globally as well. So if I run TestRPC, I think --help gives us a list of the potential. Actually, I think it just runs it. I can't remember what the help command actually is. Actually, I don't think there is a help command with the TestRPC. I think if you want to find out the actual commands for the TestRPC, you actually have to go to the GitHub repository and actually find them. But for today's tutorial, all I'm going to do is basically just use the basic bog standard TestRPC. And all that's doing is just spinning up your own version of the Ethereum network, which is isolated specifically to this instance. So running TestRPC, there we go. We actually have our own private Ethereum network running on localhost. Well, running the RPC on localhost 8545, which is the standard. Now, the next thing I'm not going to say need, but is a great tool for developing contracts within the sort of just a general IDE, and that's Atom. So if you're not going to use Remix, I would heavily suggest you use Atom, because Atom is one of the few IDEs I'm aware of, completely free, and has support for syntax highlighting, and I don't know if it has auto-completion for Solidity. So I've already got it installed, so I'm not obviously going to take through with that. Again, it's just download and install and run it. It's really straightforward. Now, obviously, once you get Atom installed, we've got this welcome page. Now, there is a thing called installer package. Now, let's open the installer. No, there you go. And we can then search for packages. So if we search for Solidity, find searching packages for Solidity, we can get a linter and an autocomplete. I actually have both of those installed already, so all you have to do is just click on the install button, wait a few minutes or a few seconds depending on your computer, and it should have them installed. Okay, so once we've got all that set up and installed, I have a blank folder here called tutorial 21. Now, we already have the TestRPC running, which is great, so we'll leave that running in the background. And we now need to basically create our environment. Now, you can create a basic bog standard environment in Truffle using Truffle init. Now, I'm actually in the tutorial 21 folder of this. I think, I'm not a big Windows command line person, but I think you actually have to use PowerShell for this. I'm more of a Linux command line person, so with Linux, you just have one terminal that just works. So I'm not too au fait with Windows. So let's just launch your Truffle init. It's going to download the template sort of like project. Now we can pretty much just leave that for now and jump back into Atom, and it's created this sort of like example structure for us. We have some Solidity contracts up here, we have some migration JavaScript here, and we have a basic set of tests and also a config file. Now this config file is kind of important, but we don't have to do too much with it today. We just have to acknowledge that we're set up in the right places. So for instance, our TestRPC was pointing at localhost 8545, which is here. So localhost 8545. We can ignore the network ID. Now the network ID is important if you're actually trying to differentiate between something like the Wrinkleby or Rompston or the mainnet or something like that. I can't remember all the indexes. I think like the mainnet is 1, Rompston is like 6. I can't remember all of them, but for now we can just leave it a star. So what's sort of in our structure? And obviously we've covered the contracts in a sort of like an overview that this is where the contracts are stored. What it'll do is create a test coin for you. So this is just called Metacoin. It's following the minimal viable token sort of concept. So this isn't ERC20 or any of the other sort of implementations of the ERC token, like 223 I think the other one is. This is just a basic minimal viable token. So you've got your balances, you've got your send coin. Actually, this isn't even a viable token, I don't think. Send coin. I think you need transfer. Oh no, it does have. No, it does an event. I don't even think this is a viable token. But either way, there we go. There's our very basic sort of implementation of our token, should we say, hence why I think it's probably called Metacoin. We also have a library to support that, and that's just got a simple converter that converts the amount of, I assume this is tokens, by a conversion rate, which is probably for the sale of coins. Not really looked at this too much, but either way, it's a very loose implementation of a coin. Now, one thing that you actually want to leave, never change, is the migration. We can change it, but personally, I wouldn't advise it. If you do anything to this migrations file, you then no longer can migrate using Truffle anymore. It's basically a dependency of the Truffle migrate, which is part of what I'm coming on to next, which is the migrations folder and the migration script. Again, you need this, and now you can modify it and extend it and so forth, but you need this migration, should we say, or the initialized migration to actually be able to migrate. So this is the first thing that gets executed. Now you may notice this 1, 2, so forth on the left hand side. This is the order in which the migrations will get executed. Because we need this migration to always be executed first, that's why it's 1_ in initial migration. So the next thing is the 2_ deploy migration contracts. Deploy contracts. and that will simply just deploy the convert lib and the Metacoin. This is just showing a very basic example of, first we need to deploy the convert lib. Now because Metacoin depends on that library, you have to then link it, so that's why we have to deploy the convert lib first. Once deployed, you can then also link it to your Metacoin. You could also do other little things with this as well, because it's kind of JavaScript and you have the whole concept of promises. You can do things such as, see if I can get the syntax right with this, function, and then so forth along these lines. So for instance, if you wanted to have a sequential order of deployments where, for instance, you need to depend on Metacoin being deployed before something else, so let's just say it's something like deployer dot I don't know, crowd sale or something like that. Actually, it needs to be deployed at crowd sale. Deploy our crowd sale, but we also want to pass it a parameter, for instance, but we need to pass it the parameter of the Metacoin address. So we can then do Metacoin, if I can get this right, Metacoin dot address. I can't remember the exact syntax. It is actually on the documentation of the Truffle homepage. I will leave a description. I will leave that in the description box down below as well. So obviously that is then stating that only deploy the crowd sale. You do have to return this as well. Only deploy the crowd sale once the Metacoin has been deployed. Then we can deploy the crowd sale with the address of the Metacoin. Now obviously that's just a very crude example. That obviously wouldn't work because we don't have a contract for it or anything. The next thing we're going to look at is the test. Now this is kind of the key reason why I use Truffle and why I like it so much, is because it has a test framework. I'm a big advocate as a software developer as a sort of like test-driven development and thoroughly testing sort of applications. And this gives you kind of two-sided way of testing things. It gives you I'm going to say an integration test as well as a unit test. Now, this is just how I perceive it. The sort of like in this example, the Metacoin JS test is, in my perspective, an integration test, because this is basically making calls to the TestRPC once your coin has been deployed. So it's testing your coin within the confines of a deployed environment. So that, in my eyes, is more of an integration test than more specifically a unit test, even though it is doing a lot of unit testing. I'm not going to go too much into this syntax. It's a very familiar syntax. It looks like, if I can remember rightly from my JavaScript testing days, it looks like Karma or Jasmine. I can never remember which one's which. I know I used to do a lot of JavaScript testing with Karma and Jasmine. I can't remember if Karma was the testing framework and Jasmine was the sort of like natural language testing syntax, but either way it looks like one of them. So you're basically saying it, and then obviously describing what should happen. So it should send coin correctly, then do your functions, and then have your assertions where saying equals so forth amount wasn't correctly taken from the sender, or something along those lines. And then I come along to what I perceive as more of a unit test, because you're actually encapsulating everything within Solidity at this point, and we're having no external sort of like interactions. I always perceive this sort of like type of testing as more of a unit test. There is a couple of things that I can highlight on this as well. So what we're doing in this first instance of test initial balance using deployed contract is we're actually getting the already deployed contract we sent from the migration. So the deployed contract migrations here is actually a reference. The deployed address is actually a reference from the contract deployed from the deploy contracts. So this is already pre-existing on the TestRPC, which kind of makes it a little less of a unit test and more of an integration test, but it's an integration test from a contract. And then the next test is a test initial balance with new Metacoin. Now this is more of what I'd see as a unit test, where we're actually creating a new instance of Metacoin and then interacting with it. Now a couple of extra things you can do with these sort of these unit tests as well is anything that has the prefix, like for instance here, of test, is actually executed as a test. So for instance, if I didn't want something executed as a test, I create it as a function, right? Function, not a test. Now that won't be executed as a test. that's just that won't be executed at all, to be honest, because it's not given any indication that it is actually need to be tested. I know in like other programming languages such as Java, you usually annotate your tests. So for instance, you'd have like at test, and that'd obviously be what indicates a test. So it kind of does it in a similar way, but uses the prefix on the function name. Now, similar as well, to kind of going back onto Java and a sort of JUnit, you have like before and after mechanisms as well, which is kind of similar to Truffle. I've not actually tested the after, I just know the before works. So for instance, if we wanted to execute something before every function call, we could do that by simply stating before, and then just pre-flight. So this is going to get executed before each function call is executed. So it will be executed one time per function. Now obviously this can be expanded. You can actually have multiple executions as well. So before, again, would obviously, I'm not sure, I think it's done in sequential order. So this will get executed first, then this, then obviously this, and then this again, and then this, or so forth. You kind of get what I mean. But either way, that is essentially, in a nutshell, the testing framework which Truffle offers to you. Now obviously I didn't go too much into the Metacoin JS sort of example, but it's quite long-winded. What I am going to do now is show you some basic things you can actually do with Truffle. So as you can see here, we've been given some basic commands. So we already have our code. I'm going to move this over here, and let's bring this over. So let's compile it, shall we? So let's do a Truffle and then compile. So that's compiling and should work absolutely fine. Because we're compiling, we don't need any TestRPC or any interaction with any network. But the next two commands we do. So we've already got our Truffle.js set up to point at our TestRPC, which is running in the background. And I will show you that when we actually deploy something, because then you can see the interactions. Now something you might have noticed is when I built the compile, it's built a build folder, which is the contract sort of like JSON dumps really. Basically this is your binary data for your contract, and then this is pretty much what got deployed to the network as your constants and so forth. Then if we wanted to, for instance, deploy the contract to all the contracts to the network, actually before I do that, I am going to state that if you are actually doing one of these folders or one of these sort of project designs, and you, for instance, didn't want to include your build, I would advise having a git ignore on this directory to ignore the build folder, because obviously you're just making this unnecessary like file, or adding these unnecessary files to your repository essentially. But either way, let's get back to deploying this to the network. Now I don't need the folder on, I don't need atom up, so I'm going to just return these back to, here we go, here. Now this is obviously the TestRPC. So if now I do a Truffle migrate, we can actually see these contracts being deployed to the network. As you see now, we're seeing activity on the TestRPC. We're seeing that obviously various things are being called, like getting accounts, get versions, sending transactions, which is going to be the submission of the contract creation to the network. It's doing like get code, which is probably a verification that this is actually working, and so forth. But now either way, that is now part of the TestRPC. So we could obviously interact with that, but interacting with that using, obviously we could use the Truffle command tools, or the Truffle command line, but it's a bit, I think it's the Truffle console, but it's a bit long-winded. So alternatively, we could test these sort of features and functionalities by simply running Truffle test. And all this will do is run the two tests that we actually had in our test folder, and then obviously make various calls to the TestRPC using the integration test, which is the JavaScript version, and then do various bits and pieces on the actual Solidity or unit test, just to make sure everything can be called and so forth. And as you can see here, everything went fine. Ignore all these warnings. I think that's just it's a bit of a sort of a legacy framework, Truffle. So obviously with moving newer and newer versions of Solidity, a lot of stuff becomes highlighted as a warning. So we can just fully ignore all that. Obviously that's kind of a bit of responsibility of the developers to sort of make sure that's up to date, but I think obviously it's got to be backwards compatible with older versions of Solidity and so forth, so either way here nor there. But we can see everything passed, so nothing failed. Let's just create a very basic scenario that we know is going to fail. Okay, so let's just create a very simple function call. So function test failure condition. So all we're going to do, similar to this one, we're going to start with a Metacoin contract, and we're going to state assert equals is, I don't know, 0. Owner should have, and to be fair, this should be, let's just call this, this should fail. Yeah, because obviously the owner of the contract should start initially with 10,000 of these Metacoins, so stating that it's going to have 0 is basically implicating that this is going to fail. So if I now bring this back over here, run the tests again, we now have 6 tests that we actually have to pass, but we're expecting one of them to fail. And it should give us the message, probably this should fail. So hopefully in a second we should, there we go, we have 1 failure on our test condition. So basically the error that is stated here is this should fail, because that's kind of the text that we've allocated to that error, and we're stating that tested 10,000 against 0. So we know it's 10,000, but we're expecting it's 0, so this is why we know it's going to fail. Now obviously you could, I'm going to implement a very simple before statement for each of these as well. So function before all, I'm just going to call it. And before all, what I'm going to do is get rid of all these instances here, assign it to here, get rid of that, and let's just state Metacoin. Let's call it meta. Doesn't actually need an access modifier, we can leave it as essentially public. This is actually stating that it's testing the balance of using a deployed contract. So what I'm going to do here is also just put a little bit of a cheat in to keep that in line. So that's going to be deployed addresses.metacoin. Okay, let's try that again. Now hopefully this should still work, but obviously one test should fail. What have I got wrong this time? Deployed, oh yes, sorry, because we're already using a predefined instance, we don't use the constructor call. What's wrong this time? Returns address to Metacoin. What was it before? Oh, it was a function call. I knew that. There we go. Hopefully I got that right this time. So again, it should be 6 tests, 1 should fail, and that is going to happen. Is it? Yes? No? Hopefully? Yes, there we go. So obviously in this scenario we've assigned meta using the before condition before each of the function calls essentially. And I'm pretty much going to wrap it up there. I don't really want to go too much into Truffle because I'm going to expand this a bit more, and sort of I'm going to do a little bit of development using Truffle. I've done quite a bit recently. I've actually published an ERC. It's causing a little bit of a debate at the moment because the ERC essentially was for standardization essentially on the microcontract architecture. Which is a spin-off really of what I perceive as the microservices architecture, which is something I've kind of looked at quite extensively and worked with in brief in the past. But yeah, obviously if you found this tutorial useful, give it a thumbs up. If you would like to stay up to date with my latest content and videos, feel free to hit the subscribe button. But until next time, good luck with developing Solidity, and I'll catch you around.